Good morning, everyone. Let us start this session. So, in the last session, I have given one example on the concurrent force system. Okay, and we have to find out the unknown tensions in the cable AB, BC, and CD. So, this problem it is the connected bodies problem where the ropes are connected to each other. So, if you observe the different parts of the cables AB, BC, and CD, okay, they are connected at point B and at point C. And we have two loads P and Q hanging at the point B and C. Okay, so P is given 50 kilonewton, and we have to find out the load Q and the tension in the different portions. Okay, so to solve this problem, first draw the free body diagram for the point B and point C. So you can observe here, this is the point B. So at point B, the one force P in the downward direction. Okay. Next is the tension in the cable BC. So this is the tension in the cable BC. And then we have the tension in the cable AB. So this is tension in the cable AB. Okay. So here force P is given, which is equal to 50 kilonewton. But tension BC and tension AB both are unknown. So this angle, this is equal to 60 degree. Because this angle is given 60 degree. So if you draw one horizontal line, so this will be the alternate angle. So this is 60. This is 75 degree with respect to y-axis. So this angle is a 75 degree. Okay. So here you can use the summation fx and summation fy, and you can find out the value for tension BC and tension AB. Now draw the free body diagram for the point C. So at point C, this is the force Q, which is the unknown. Then here we have the force CD, that is the tension in the cable CD. Okay, so consider point C. This is force Q. Now here we have the common tension BC. Okay, just direction is opposite at point B and at point C. So this is tension BC. And this is tension CD. Okay, so at the point C, show the tension directed away from that point. Okay, so this is the free body diagram for the point C. Now here the angle of tension CD with respect to x-axis, this is equal to 30 degree. Okay, so you can draw one horizontal line at this point. So this angle, this is equal to angle 30 degree. Okay, now here the angle is not given for the BC with respect to x-axis. Okay, but this 75 is given. So if you extend this line, the force P, that is this vector, is exactly vertical. So this is 90 degree. This is 75 degree. So the remaining angle, this is equal to 15 degree. Okay. So this angle, this is equal to 15 degree. Okay. So now first we have to solve this free body diagram, and then we can solve this free body diagram, because in this free body diagram we have three unknowns. Tension CD is unknown, tension BC is unknown, and the force Q is unknown. Okay, so we have total three unknowns, and for the concurrent force system, just we have two equations, summation fx0 and summation fy0. So you cannot solve this free body diagram directly. So first solve this free body diagram, and then calculate the value of common tension BC. So either solve this by summation fx, summation fy, or by using the Lamy's theorem. Okay, so if you want to use the Lamy's theorem, then we must know all the angles. So here for tension AB, opposite angle is 75 degree. For tension BC, this total angle, This is 90 plus 60. So this is equal to 150. So 150, 75. So the remaining angle. So this is 135. Okay, so this total angle is 135 degree. So now you can use the Lamy's theorem. So first is tangent AB upon the sine of the opposite angle. So this is equal to 75. This is equal to the force P upon the sine of opposite angle. So 135. And the next we have tangent BC and sine of the opposite angle. So it is sine 150. Okay. The force P is given. This is equal to 15 Newton or 50 kilonewton. Okay. So this is 50 kilonewton. So now equate these two values and get the value of tension AB. Okay. And from the remaining two, you will get the value of tension BC. So the tension AB, this is equal to 68.3 kilonewton. Tension BC is equal to 35.35 kilonewton. Okay. Now for the second free body diagram, you can use the Lamy's theorem. Okay. So just find out this total angle. So this is 90 plus 15. So this is equal to 105. Okay. This is 90 plus 30. So this is equal to 120. And this is 360 minus 105 minus 120. So this is equal to 135. Okay. So write the equation. The force Q, which is the unknown, upon sine 135. Known force is tension BC. So this is 35.35 upon the sine of opposite angle for tension BC is 120. And unknown value tension CD upon the sine of opposite angle. This is sine 105. Okay. So solve these equations and get the value for the unknown load, which is a Q. So this is 28.86 kilonewton. And the tension CD, this is equal to this is 39.43. Okay. So just check the answers. Okay, so refer this next problem. So here one weight 30 kg is supported by the 5 cords. Okay. So we have to determine the force in each cord for the equilibrium. Okay. So here we have 2 points for the equilibrium. One is a point B and second is the point A. So weight 30 kg is connected to the point A. So you can draw the free body diagram for point A. So this is the horizontal cord AE. So here we have the tension AE. Okay. Then we have the weight in the downward direction. So this is 30 kg. So convert that kg in Newton. So this is 30 into 9.81. And this is the common segment, which is the AB. So this is tension AB. Okay. And for this tension, its angle is given, which is 60 degree. So this is the free body diagram for the point A. Then consider the next point, which is the point B. So at the point B, tension AB is common. Okay, just direction is opposite. So this is tension AB. Then we have the segment BC. So this is the tension BC. and then we have the tension BD. Okay. Now for tension AB, angle is same. So this is 60 degree. So this angle will be 60 degree. So just observe here in the diagram. If you draw one horizontal line, this is 60 degree. So this will be the alternate angle. So this is also 60 degree. Okay. Tension BC is exactly horizontal. For tension BD, the angle is not given. Okay. But the dimension is given 3, 4. So if you consider this angle to be alpha, then alpha is equal to the tan inverse 3 by 4. So this is 36.86. So this angle with respect to x-axis, this is 36.86. Okay. Now here, if you observe this free body diagram, then in the second free body diagram, we have three unknowns: tension BD, tension AB, and tension BC. Okay, so we cannot solve this directly. So we should solve the first free body diagram where we can find out the tension AB and tension AE. So consider this free body diagram for the point A. So you can use the Lamy's theorem. So this angle, it is 90 degree. This total angle is 90 plus 60. So this is a 150. So 150 minus 19 and 360. So this is a 120. Okay. So now write the equation for Lamy's theorem. So we have tension AB upon the sine of opposite angle. So it is a sine 90. This is equal to the known value is 30 into 9.81 upon the sine of opposite angle. So it is a sine 120 and tension AE upon the sine of opposite angle. So it is a 150. Okay. So from this calculate the value for tension AB and tension AE. For second FBD, we need this value tension AB. Okay, so just solve the equation and give the answer in the chat box. Okay, so now we will see the problem on the equilibrium of parallel forces. So here we have one rod AB, and this rod AB is supported at the point A and B, sorry, at point A and C. So at point A, we have the hinge support, and at point C, so this is the roller support. So this is the point C, and the forces are like this. So we have 20 kilonewton. It is at distance D, sorry, at 2 meter. Next we have 20 kilonewton, again at 2 meter distance. Okay, so this is the given condition. The rod AB is supported at point A by hinge support and at point C by the roller support, and it is subjected to 4 forces of 20 kilonewton. Okay, as shown in the figure. The question is find the reactions at the support A and C. Okay, so we have to find out the support reactions. So here your first step will be, we should draw the free body diagram for the given system. Okay, so in the last lecture we have seen the types of load and types of support. Okay, so here at point A we have the hinge support. So we know if there is a hinge support, then there are two reactions. Okay, so at this point, these are the two reactions. One is a HA and second is the VA. And for the roller support, there is one reaction. Suppose this is the roller support. Okay, then this is the vertical reaction R. So first step, we have to draw the free body diagram. So draw the beam AB or rod AB. Okay, so next, show the external forces as it is. Okay, and then the hinge support we will show as a reaction VA and HA. So at the point A, we will have two reactions. So this is a VA and this is HA. And at the point C, there is one reaction. So this is the RC. And this reaction, actually it is perpendicular to this horizontal line. So right now, the roller support is exactly horizontal. So reaction RC will be exactly vertical or perpendicular to the rod AB. Okay. Now here, if you observe the number of unknowns, okay, that is the reactions. So HA, VA and RC. So we have total three reactions. So HA, VA and the reaction RC. So in order to find out these three reactions, we will use three conditions of equilibrium. Okay. So the condition will be summation Fx, this is equal to 0. Second condition will be summation Fy is equal to 0. And next condition is summation of moment, it is equal to 0. Okay. So by using these three conditions of equilibrium, we can find out the unknown values HA, VA and reaction RC. So try to find out this summation Fx is equal to 0. So for the summation Fx, we will consider the HA and there is no other force for summation Fx. So we can write down summation Fx, this is equal to 0. Okay. So first is HA. So you can consider HA on the negative direction or in the positive direction. Okay. So right now we have considered HA on the positive side. So this is a plus HA. So only one force in the x direction. So this is equal to 0. Okay. So directly you will get the value of HA as a 0. That means there is no reaction at point A in the horizontal direction. So what is the reason HA is 0? Because if you observe the given diagram, then there is no force in the x direction, that is external force, and therefore HA is 0. Then use summation Fy, this is equal to 0. Okay. So for summation Fy, So for summation Fy, consider the forces in the y direction. So we have 20, 20, 20 and 20, all are in negative direction. So minus 20, minus 20, minus 20. And one force Va in the positive direction. So plus Va and this plus Rc. Okay, so this is equal to 0. And from this you will get the equation as Va plus Rc, this is equal to, so this is 80. Okay, so you can take this as the equation 1. So Va plus Rc is equal to 80. Now in this equation, we have two unknowns. One is Va and Rc. Okay. Now use the third equation, which is summation of moment. So for the summation of moment, you can take the moment about point A. Okay, so whenever we use the summation of moment equation, then you should select the point where you can cancel the moment by the remaining unknowns. Okay, so here we have three unknowns. One is a Va, Ha and the Rc. Okay, so at point A we have two unknowns. Okay, one is Va and Ha. So we can cancel out the moment directly if we select the A point as a moment point. So from this equation we can directly find out the value of the reaction Rc. And therefore I have selected point A as a moment point. So now write this equation, summation of moment by all the forces about the point A, this is equal to 0. So this is the third condition of equilibrium. So start from the point A only. So there is a Va force and Ha force. So directly this moment is 0. Okay. Next is 20 into the perpendicular distance for this force is 2 meters. And this moment, it is a clockwise. Okay. So this is negative. Next is 20 and distance is 4 meters. And this moment is clockwise. So it is negative. Next we have Rc and distance is 6 meters. So and this moment is anti-clockwise. Okay. So this is the direction of rotation. So this is a positive. Next is 20 and the total distance is 8 meters. And this is clockwise, so it is negative. And then we have 20 and total distance, so 10 meters. And again this moment is clockwise, so it is negative. So this is equal to 0. Okay, so from this equation you can directly find out the value of reaction Rc. Okay, so just calculate this value. Okay, so from this equation of summation of moment, you will get the value of reaction Rc as 80 kilonewton. It is not Newton meter. Rc is the reaction. Okay, that means it is a force. So unit will be kilonewton. And the direction of Rc, it is exactly in the upward direction, that is a positive y direction. Now from equation 1, you will get the Va reaction. So Va plus Rc, which is 80, this is equal to 80. Okay. So Va value is also 0. So there is no reaction at point A. So reason is actually if you observe this RC, okay, so RC is exactly at the center of these loads. So 20, so they are at distance 2 meter and 4 meter. And also on the right hand side, this 20 and this 20, they are at the same distance. Okay. And therefore at this point, we don't have any reaction. So if you slightly change the distance, so instead of 2, if you take the 1 distance, then you will get some reaction at the point A, that is a V.